calm. We have simplified. We have multiplied and divided a little bit. And we've added and subtracted these rational expressions as well. Okay? What we're getting ready to do is like two things in one. Complex fractions, and you've already seen them in Algebra 2, but complex fractions are just fractions within fractions, okay? It's a fraction divided by a fraction. And Mr. Gammons, I know when it was a monomial over monomial divided by a monomial over monomial, he showed you how to do that bracket thing, like this right here. And y'all get it. I never get it because I remember, and you guys have been with me now several days, and you know I always go back to elementary school. I had some good teachers, and I learned in elementary school. I really did. And now that I'm teaching, I understand how much I learned and how much I appreciate what they did. But whenever you have a fraction divided by a fraction, this, I understand it after I do the problem my way, okay? You may do the bracket thing. I have to do my thing, which is this. Numerator divided by denominator. And what I do, and you'll hear me refer to this all the time, this is old school. Because it is old school. It's old-timey division. Okay? And that's what I'm going to do. The only time you won't do this is if you have a monomial over a monomial divided by a monomial over a monomial. Then even I can do the brackets, but that's the only time. Okay? So, are they wanting to get in here, or are they talking to each other? Because y'all like peeping out the window. They don't need me, right? Okay. All right. So let's look at this. Let's do one with the bracket. I have no idea what this is going to be. I'm making this up right out of my head right here in front of you. Who knows? It's probably going to be awful, but we'll give it a whirl. Okay? A monomial divided by, well, fraction divided by fraction. Here we go. 3xy over z squared divided by, I have no idea what this is going to be, folks. Let's go z cubed divided by 4x squared y to the fourth. And for whatever reason, because y'all know how strange I am, I always have to put little dots on the end. Because I need to clearly separate my two fractions. I know it's weird. Just say it's all right. Whatever. You don't have to do the dots. I have to. You guys can do that bracket thing. And it's something like this. But I can draw the brackets, but I don't know what to do with the brackets until I see it my way. Okay? Now, how many of you have seen Mr. Gammon's bracket thing? All right, y'all know the bracket thing, and you're going to help me with the bracket thing. But I've got to set up this for me. Old school. Everybody write this down because this will benefit you when we get these nasty complex fractions, okay? Old school is going to be my numerator divided by my denominator. Yeah, this is going to be ugly. It's not going to be pretty at all. But isn't that what a fraction is? Isn't it the top number divided by the bottom number? That's what it is. I'm not doing anything new. I'm doing what we already know. And then old school division, folks, what do we have to do? You always heard it in elementary school. 3 words. Copy, change, change, but I like it copy, change, flip. Just because. Copy, change, flip. Going back to what I did, what I understand. Copy 3xy over z squared times the reciprocal which is 4x squared y to the 4th over z cubed. Yeah, and this is going to end up being ugly, but we can deal with it. What's that numerator going to be? 12 who? X cubed, y to the 5th, over z to the who? To the 5th. Do you guys agree with that? A few little nods, yeah, thank you. That's old school. That's easy. And some of you are like, I ain't doing all that. I'm going to do the brackets. I'm going to do all that work in my head. Go ahead. But who's going to be more likely to make a careless mistake? You are. Not me. You are. So let's look at the bracket thing. I don't know what to call it, but other than bracket thing. How do you do it? Yet, see, now is when I have to look at it. It's going to be the top times the very bottom, right? Divided by the product of these two. Is that it? Y'all the ones that do the brackets. Is that right? Do you write it in a fraction? All right, 3xy times 4xy squared y to the 4th divided by, is that right? Z squared times z cubed. Now that does save steps. I'll agree with you. But the only time you can do this is when it's a nice, neat little complex fraction. If you try to do it any other time, I'd almost bank on, you can do it. But I'm going to put my money on this right here every time. But that works. And we still get the same answer, 12x cubed y to the 5th over z to the 5th. Whole lot fewer steps. Is it doable? Either way is doable, folks, okay? I just want you to see it and understand both ways. Everybody cool? Questions? All right, so let's look at another problem where it's not so easy to go with the brackets. I would go brackets if it were a monomial divided by these monomials. But if it's a binomial or anything else, I'd go old school every time. Okay? Here we go. Let's look at another one. If I were to give you x plus x over 3 divided by x minus x over 6. For all practical purposes, we've got a binomial over a binomial, right? So you can't go brackets on this. You have to go old school. So we're going to write numerator divided by denominator. Now I'm going to just tell you, I am a parentheses ninja. I will write parentheses around everything. And let me explain why I do that. Y'all know that I'm a little unfocused at times. If I don't put parentheses around things, I get completely lost in my own work. And my work is pretty neat, and I want to keep it neat. I want you to keep your work neat, because the neater you keep your work, the easier it is for me to follow. The easier it is for me to give you partial credit, okay? So I'm going to take my numerator, and I'm going to divide it by the denominator. Don't we have two problems in one? It's two problems in one. So I would never give you a quiz of 25 of these or a test of 25 of these, because some of us, it would take us 2 blocks to do these jacked up problems. It would take me that long, okay? What do I need to do with the first set of parentheses? What do I have to do to it? Say it again. Copy it down. Yeah, but not yet. What do I need to do before I copy, change, flip anything? I got to find the common denominator, okay? Because right now the x's denominator is what, folks? 1. And isn't it 1 over here too? Now, common denominator. Because I'm seriously going to treat this as one problem divided by another one. Here we go. What's my denominator for that first set of parentheses? Of course, it's 3 The second one doesn't change at all. 1 times 3 is 3, so that means I have to multiply 3 to the top. 3x, do you guys agree with that? Okay. Divided by, what's my denominator for the second one? 6, of course. This one doesn't change. 6x on top. Right on. Now can I write one fraction? Everything is one fraction. What's 3x plus x? 4x. Divided by 3 divided by. 6x minus x is what? 5x. And now what do? Copy, change, flip. Copy, change, change. What happens? What happens, folks? I can cross cancel. Cross cancel, my 3 goes into 3 one time, 3 goes into 6 two times. Anything else? Can I cross cancel the x's? They cancel completely out. What am I left with? 4 times 2 is 8. 1 times 5 is 5. Are you kidding me? Look what we started with. Are you kidding me? We're going to get a number, and we started with that thing right there. Why? That blows my mind. Who would have, whoever created it gave me a job, provided me with a job. But why? How is this relevant to buying groceries? Now you can buy a gallon of milk, folks. Your family will never go hungry. All good folks need to know how to do these problems. Your parents know how to do it. They can all buy milk at the store. They are so smart. For real. This is a requirement. Just saying. Questions? Facile or difficile? This is facile. This is easy. This is easy. Let's look at another one. Or not. Yep, let's go. Oh yeah, let's look at this one. 2 over x minus y plus 1 over x plus y over okay. Have I done this one? Yeah. Not yet. Thank you. Oh, Lord. What are you trying to do? What's that word? Common denominators. All right, before I even do that, though, I'm going to rewrite this thing, old school. Okay? Here we go. 2 over x minus y plus 1 over x plus y divided by 1 over x minus y. I cannot force you, I guess I could, but I would never, to do this problem vertically. I cannot follow your work if it's side to side. I have a very difficult time. I do these problems vertically. It'll be easier on you to follow your own work, okay? Now, Christian, you said common denominator, right? Folks, if I've got x minus y and x plus y, what is my common denominator going to be? It's going to be the product of those two, isn't it? Okay? Because I'm going to forget about this right now. I don't need to do anything with the right side of this problem. I've got to get a common denominator. Not going to do anything with the right side. It stays the same. Okay? Everybody following me so far? I can tell some of you are. Some of you are in outer space right now. What did I multiply to that first fraction? X plus y. So what I do to the bottom, I have to do to the top, right? Don't forget to bring down your 2. What am I going to multiply to the top of the second one? X minus y. Do I need to worry about that 1? Do I need to worry about the 1? Nah, because 1 times anything is that thing, right? All right, so now what? Look at it. Talk to me. Distribute. Distribute the 2. So it's going to give me 2x plus 2y. Can I go ahead and write this first set of brackets as one fraction? Plus x minus y. Because they have common denominators, don't they? Do you see what I'm doing? Yeah? Okay. Christmas lights up here. Now what? Talk to me, come on. Combine like terms. So I've got 2x and x, 2y, negative y. What is 2x plus x, everybody? 3x plus who? Plain old y. 2y minus 1y is 1y. And now, what am I going to do? Copy, change, flip. I've got it copied. I'm changing division to multiplication. I'm going to flip. And what now? Why should I? Now, to make this easier on me now, if I cross cancel, just because I did not put parentheses around this x minus y, does it mean anything? Is it untouchable? No. It's still a binomial, and it's still going to cancel out with that one. Now I'm going to multiply across, and it's going to, what's left up here, by the way? A 1, good. 3x plus y times 1 is 3x plus y over who? X plus y. Ooh, I can cancel out the x's and the y's, right? Because this thing goes into itself 1 time. This goes into itself 1 time. This times 1 is this. Okay? That's why. It is, but no, it is common sense for some folks. Okay? I don't mean that as I'm just saying. Some people need to see it. Am I done? I can't cancel anything else out, Seth? I can't cancel out those y's? Would the teacher be trying to trip you up right now? Yeah. Can I cancel anything else out, folks? No, because we got 3x plus y on top, and we got a plain old x plus y on the bottom. We're done. That's all we can do with that. Comprende? See? How are we with this? How many of you got it? I see. How many of you are like, I see? It's all good. How many of you are like, please don't. I hate this stuff. I know. Some of you are like, I'm raising my hand on the inside. 3, one more. Can we go with one more? How much time do we have? What block is this? This is second. Geez, see, I don't even know. God. One more. Seriously, we're only doing one more. I'm not playing. I'm being for real. So that would make this example 5. Okay, see, what would I do without y'all? Here we go. If you couldn't tell me what block it was, what example to do, you want to try this one on your own? Try this one. Work with each other. Okay. All right. It's probably, of course, it's recording now. Yep. Here we go. The answer is, what is it, Tyler? 15 times the quantity. 2 plus x, all of that over 8. All right, one more time. The answer is 15 times the quantity. 2 plus x, All of that over 8. How many of you had that? High five. Good job. All right, but you were there. Weren't you within reach? I think you were. All right, so let's look at this. The thing you got to realize, folks, is you got to separate this into the numerator divided by, stop talking, the denominator. Okay? So here we go. Let's check this out. Just treat it as one problem. Just say, okay, forget it. If it's too much for you to look at, then do that much. What do I need to do with those fractions? Common denominator. We got 2 and 4. What's my common denominator? 4. All right, here we go. 4 and 4. This one doesn't change. What did I multiply? I multiplied 2, so 2 times x is 2x. Y'all cool with that? All right, covered up. We're done with that. Because some of us literally need to cover that up. What's the common denominator of 3 and 5? 15, of course. 3 goes into 15 5 times. 5 times x is 5x. 5 times 3, 3 times x. There we go. What's 5x minus 3x? 2x. What about this one? Because I just went ahead and said, all right, did I copy that right? Yep, all right. How do I combine 2x plus x squared? Oh, Michael. I'm sorry. It got me. See? Still recording all that. It just, well, I don't want to snot on anybody like I just did. I didn't mean to do that. I didn't snot on it. Excuse me. Can I literally combine 2x plus x squared? Or do I just have to smash them together? I just have to smash them together. They have to be combined with an addition sign. But that's all I can do. I can't literally put them together. Can't add them together. Looks funny because I want it in, bless you. She snotted on you, Nathan. There we go. That girl. We like for them to be in decreasing order, descending order. It doesn't really matter. But I do want you to look at it this way. Copy, change, flip. Before I do anything, I want to simplify up here before I simplify at the end. Is there anything I can do to x squared plus 2x? I can factor out a GCF. Let's just look at that real quickly. I'm going to write everything down. Is there anything that I can cross-cancel out of that? What can I cross-cancel? The x's, the plain old x's. Anything else? How about this 2 with this 2? No, because this is part of a monomial. That's part of a binomial. Don't be messing with my man, right? What do I do now? Multiply straight across. 15, because I like my number to be there in the front, times that quantity, x plus 2, over who? 4 times 2, which is 8. Folks, I am totally fine with you leaving your answer just like that. If you distribute the 15 and got 15x plus 30 over 8, that's fine too. It's the same thing. It's like having 4 quarters and a dollar bill. Still the same value, it just looks different. Okay? What do you think? Is this doable? Now, we've just touched it today because I'm going to have so many students out of third block. So, lucky for y'all, we're not really, we've worked, but we haven't worked like we should. We'll have to go finish up complex fractions tomorrow. So that means today, if we're kind of in shallow water, tomorrow, better bring your life jackets if you can't swim because we go into the deep ends, okay? You better get ready. Better get ready. Questions on these at all? Work hard, folks. If you do nothing, you get nothing. You work hard, you'll get something out of it. You really will. All right, here's what you're going to do for me. Can everybody see those 5 problems? I had to throw in there the bracket thing to make some of you happy. Because you're like, got this. 1 and 2, easy, easy, easy. 3, 4, and 5, they progressively, obviously you can look at them and tell, they progressively get more difficult. 5 is going to be a funky looking numerator. I'm telling you right now, already. Don't be rattled by it. It's easy, but it's going to be a very strange looking numerator. Everybody cool? This is just straight up board work. I told you we'd go old school. Everybody work.